very much. Okay, guys, hello. We are going to end up with some nice personalized training today with only 2 of you on the call. So, hello.
Hello.
We can, yeah, literally. I mean, normally we'll be able to say, don't have your mics on. But if you do want to interrupt me at any point, we're going to probably be able to do that today. So if we haven't met before, my name is Bradley and I work for LGfL, London Grid for Learning, and I am the computing lead in LGfL. Before I worked for LGfL, I've roughly worked there for 3 years. I was a out-of-class computing specialist teacher. I'm a CAS master teacher, a lead practitioner in computing, and I'm an Apple APLS, so an Apple Professional Learning Specialist. What we're going to be looking at today is the bit that people find the hardest with the subject overall of computing, and that's computing science. So we're going to dive a bit deeper into that, and we're going to be looking at LGfL resources at the same time. So hopefully that's kind of why you're here and what you're here for. Now I'll have my PowerPoint going on behind me. So instead of presenting a screen, the PowerPoint will be behind me the whole time. Hopefully that works for you guys and it'll work for me. So if you haven't, just very quickly let you know a bit more about what LGfL is. If you've had any of these talks before, I do apologize. They always end up being the same. We are an organization that, although buys and sells internet to your school, we're actually a charity. So you might not know that we're a charitable trust with charitable aims. We're here to help schools save money. And, you know, with the Leo Academy, we're doing our best to constantly help you guys out as much as we can. So we've got charitable aims: saving schools money, keeping children safe, tackle inequality, energize teaching and learning, and enhance well-being. Now, I am part of the teaching team, and we're called Inspire. And the teaching team are a group of teachers from secondary school and primary school. So my strengths were computing, but I was also the early years teacher. So I've always been an early years teacher and always been computing. So we're a good mix. And our kind of role in as an Inspire team is to get content into schools, making sure the content that, you know, we're making and buying for you is actually getting used, because there's nothing worse than knowing that there's good content, knowing we're making good resources, and they're not being used to their fullest. Now, I, as the computing lead, have a couple of extra add-ons to that, and one of them is just to get computing taught more. So I'm there to make sure that, as long as my other roles are, is to actually get computing taught more within school, get it taught to a certain level, and show people just the resources that we have that can support that. Now, it goes back to looking, obviously, at what the government asks us to do. And sorry, I close my window. Although it might look like I'm in a lovely studio somewhere, guys, I am literally in my attic, and I've got a window to my right, and it's hot. So I'll keep opening it, but then it rains and I have to close it. So the government give us this. This is the kind of guidance the government gave us many, many years ago about the new computing curriculum. Now, you get a lot of times people saying it's a new computing curriculum. In terms of subjects, computing is still very much new compared to maths and English, but it's been around quite a long time now. But a lot of the time, and all of the reports are coming out, that computing, and especially computer science, is still a really shaky subject. It's one that if you've got a timetable, it's normally one of the first subjects that gets booted out the door, because you've got, you know, singing practice, or you've got more maths, so you have to finish off your writing. So computing always kind of gets left behind. One of the things I always want to show people, though, is that there's always a fear of computing, a misunderstanding of what's there and what you have to teach. And sometimes we can get frightened when we look at, you know, people on social media. If you're on Facebook or on Twitter and you follow teachers, sometimes, you know, people will show their best side, and schools will show their best computing. And, you know, there will be robots, and there'll be amazing projects, and there'll be amazing kind of complicated pieces of code. And sometimes that's really inspiring, but also that can be quite demeaning, demoralizing, that you look at and you think, I can't do that. I don't know how they've got there. And I always want to bring it back to this document, because inside of this document, there isn't that much to do. Once you kind of get that, we're going to pull out some strands, and we're going to focus on those heavily tonight. And once you look at those and see how easy it is to answer them, you'll actually think, oh, actually, computing's for me. Because that's the other thing that people will say, oh, you know, computers don't like me, or I find this difficult. You know, we can't say that about any other subject. When we have maths, you know, or English, I I hate phonics. Oh, you could imagine as an early years teacher saying, well, I'm not sure about phonics. Phonics doesn't like me. I'm not going to teach it. It wouldn't happen. But with computing, it's sometimes said, you know, well, I'm really frightened of computers. I'm not going to do it. I think if we go in and actually unpick what's here, you'll be less frightened. Now, guys, I'm going to share this PowerPoint with you. I'll share it at the end. But inside of computing, there isn't that much there to actually look at. One of the key points in Key Stage 1 is thinking about computational thinking. So it's skills associated with programming, breaking down processes into a sequence, turning algorithms into code, but using it with toys such as bee-bots or floor robots. You might want to start using a language like Scratch Junior or something like that. But the key points in Key Stage 1 and early years is playing with computational thinking, thinking like a computer, breaking down processes, and actually, you know, using something like a floor robot, which is quite practical. So inside Key Stage 1 and early years, there isn't that much really to worry about. It's when it gets into Key Stage 2 and people start listening to the word code and hear the word coding, and that can make people quite nervous. So as pupils develop experience in programming, they will use 3 constructs with their code: sequence, selection, and repetition. They will also use inputs and outputs and variables. And it's at this point when people see this and go, don't know what those are. I know what addition is. I know what multiplication is. Sequence, selection, not sure about those. And that's where, you know, the kind of fear and the kind of idea of computing became quite hard, because at the time when computing was a new subject, there was no CPD introduced. And even now, computing training is incredibly low down in the list for training in a normal situation. So what we're going to be looking at today is more about sequence, selection, repetition, variables, inputs and outputs, what those look like, and what LGfL has to answer those resources. Now, I will talk for a bit, but there will be a point when I'm going to ask you to have a little play and start playing around with these resources too. Now, obviously, in a nicer world, we'd be doing this face to face, so I can start, but I'll do a bit more talking, and then we'll go into maybe looking at these resources. But as I talk about them, you know, open up another tab. Make sure you keep the Google Meet pinned, so you've got that tab pinned. But do open up another tab and have a look. One of the first things I wanted to show you guys was computing.lgfl.net. So this is a resource built inside of LGfL that actually does something. It breaks down the resources for you. Because when we talk about computing as a whole, sometimes we get kind of confused of what it is. Computing as a whole is actually 3 different strands: information technology, digital literacy, and computing science. There are 3 different strands. Now, we're not going to be looking at IT, information technology. We're not going to be looking at online safety day. Our major kind of focus will be computer science. But for more detail on those other resources, if you go to computing.lgfl.net, you will see that I've broken down all of the resources, so you can see how we've got resources for IT, for online safety. Well, what we're going to do today is we're going to dig deeper into computer science and kind of have a kind of play around with some vital resources. And these resources will kind of show you simple concepts that you should be teaching your students. Now, before we do it, it's just, you know, there's a real quick diagram here to explain to you just how small coding is in the kind of larger scale of what we're teaching in primary. You can see that computational thinking is actually a much bigger concept. You know, being able to break problems down, putting problems into sequence, debugging, you know, looking at mistakes and getting rid of them. That kind of side of it is a lot bigger. And computational thinking with computer science doesn't always equal sitting down, typing, and doing code. It can be doing any range of programming. using it like a floor robot. It can be physical computing where, you're controlling devices, and it can also just be planning a dance or actually physically moving. So computational thinking, computer science are there, but coding is a small part of it. But it's the part we're going to look at today, because especially in Key Stage 2, it becomes more of a subject you would teach. The second resource I'm going to show you today is actually a new resource. It's called Computing Spotlight. And we're not going to have time to dive deep into this today, but just to make you aware that actually there's some of the stuff I'm showing you today, I've actually put into lesson plans. So in Computing Spotlight, I've gone through the sequence of what there is, what you should be teaching from years 1 to year 6. Starts with sequence, then introducing block coding, then repetition, then selection, then events, and then variables. And I've actually gone in and made some planning for you. So we're not going to dive deeper into that, but each one of those tiles links to lessons that I've planned. Each sequence has 3 lessons, and they're designed to support you introducing computing if you haven't got that in your curriculum at the moment. And we go through a process of going through Unplugged, Busy Code, and I'll explain what that is in a moment, and J2E. So Unplugged is kind of using computational thinking without using a computer. So kind of really simple unplugged exercises that are really useful. Busy Code is a platform inside of Busy Things, and we're going to talk about that. It's block-based. And J2E, and you might have used J2E tools before, is another tool that we have on LGfL. So what we're going to be focusing on mainly today is Busy Things resources, and we're going to explore computing concepts using Busy Things resources. And inside of Busy Things, you've got computing, early coding, and actual coding too. So that's one of our focuses today. And the other range of resources we're going to be looking at are the Just Too Easy Tool Suite tools, and we're going to be looking at the J2 code resources that are in there. And hopefully that will make some sense as we go along. So what we're going to do today is we're going to look at the strand, the kind of key concept, and then from there, we're going to have a little play, and you guys are going to have a chance to explore that concept in real life. And hopefully, once you do that, you can kind of get a feel of what their concepts are and how you can teach them to your students. Does that sound good? Does that sound okay?
Perfect.
Good.
Yeah, great.
Brilliant. Fantastic. Okay. So the first thing that we look at, and it's the most simple thing, and this is the, and I'm going to try to open my window up again, is sequence. Sequence is the beginning of coding. It's the beginning of computational thinking. And when you're thinking about sequence, you're doing it all of the time. You're just not calling it computing. So a sequence is when we arrange something in a particular order. When we're thinking about computing and computers, it's really important very early on for students to understand that computers are not clever. Computers are not smart. Computers have not got, this kind of personality. They can only do what they're told. And that's one of the things when we look at robots in early years that sometimes we get wrong. So for example, when we're using B-bots, when the B-bot makes, when there's a mistake with a B-bot, there are sometimes that kind of talk of, oh, B-bot made a mistake, or, oh, B-bot's gone off here and decided to do that. We need to kind of crush that very early on, because B-bot hasn't made a mistake. Somebody's made a mistake, right? If a computer fails, it's not the computer. It might be broken, but there's a mistake inside of it. Normally, how things get, don't work is because of human error. That it's the human who's actually interfering with the computer. So it's important to understand that computers are quite basic and need simple sequences to get them started. And all code, any kind of baseline code, starts with some simple sequencing. And from year 1 all the way up to year 6, you need to understand that there is a sequence of code. And at the beginning, you just need to understand it's linear, so it goes one way. And that kind of can link to the everyday world. So how does that look in real life? Well, how to make toast. There are going to be some sequences that kind of don't have to always go in the right order. So it's important to make sure when you do show students a sequence, that it's a sequence that does have to go in a particular order. Because, for example, getting dressed can be, you know, some people put their socks on before they put the trousers on, etc. So it's important to try to give them a sequence that does make logical sense and has to go in a particular way. So, for example, making toast, slicing bread, although who slices bread anymore? Not many people. Well, maybe more now that we're in lockdown, right? Everyone's making bread. Slice bread, toast bread, butter toast, add jam, put on plate. So simple at the very beginning to explain sequences to students. You do stuff like this, and you're doing that all of the time. Instructional writing. Anytime you're thinking about planting a seed, brushing their teeth, any of those kind of things. And children's lives are built around sequence and visual timetables and the calendar. So you're constantly introducing sequence. It's important to always remember that that links into code. So, for example, here's a piece of code in Scratch, and this is just one type of block coding. And this is what a sequence of code would look like for most primary Key Stage 2 students. And also, it's important to remind them that this is code for children to use, but as they get older, they need to understand that this is code with support. You know, there are other types of code as well. So with sequence, what we're going to do now is we're going to dive deep in to use busy things, and I'm going to go live in a minute. I'm going to go pop into an actual website. But first of all, I'm not sure if you guys can log into busy things. If you guys can log into busy things in the normal way for you, which would be busythings.lgfl.net, and use your USOs, please do. If you don't have your USO handy today, or you're on a computer that doesn't have that saved, today I've made you a demo password and a way of going in. So if you just want to log into Busy Things now using this, it's busythings.co.uk, so a slightly different web address, and the username and password is demo.lgfl, demo.lgfl. So open up a new tab, go to busythings.co.uk and go demo.lgfl, demo.lgfl, and that will log you in. And when you're there, let me know. And I'm going to jump over onto a live version. Is that okay, guys? Have you got that login?
I'm logged in. Thank you.
Brilliant.
Yeah, just doing it now. Thank you.
No worries. And that's just a login to use today, because sometimes people just don't have their USOs handy. This is a quick demo that you can use while we're here. So when we're in, you can kind of see there's banks of stuff, and you guys are using Busy Things, I know, at the Leo Academy really well. What I wanted to show you, we're going to go into, and the reason why we're going to go here up into Key Stage 2 is because it will show you all of the resources in one go. If we looked in early years of Key Stage 1, we wouldn't see everything in one go. So we're going to just go into Key Stage 2, so you can do this alongside me. You go into Key Stage 2, go to year 5 and 6 setup. Wait a bit because I'm obviously with the meat, and then go into computing, and then we're going to go into busy code, that one in the middle there. And then from busy code, we're going to go into code disco. Now, if you haven't used busy code before, it's basically like a whole coding platform built inside of Busy Things. Now, it is one of those things that a lot of the time we assume that Busy Things might be just for early years, but there's so much in here for Key Stage 2 that you might not know about. So today we're going to be diving more really into busy code, and we'll be jumping in and out while I explain a couple of things to you. So when you go into busy code, what you will see to begin is that there's an online guide or a printable guide. So you can just, if you go into the online guide, you see already there's kind of a guide that shows you how to use this resource. It's really good, gives you lots of guidance, gives you clues on how to use the resource. Really, really good. At the very end there, if you go to printable guides, so where it says Code Disco at the very end, there's printable guides. When you click on that, you can print all of these plans out as paper, but there's also a printable demonstration code blocks. So any of the blocks we're going to be looking at today, this code that we're looking at, you can actually print out the blocks to have them for demo purposes. So it's a really useful thing to know about then, there and there. What we're going to do first is we're going to go into Code Disco Section 1. And this is the basics. And this is really designed to introduce the beginning of block coding. Now remember, this is just one type of block code, and you guys might be using Google CS First, you might be using Scratch. For me, I would prefer children to use as many different types of block coding as they can. There's different ones out there. There's Hopscotch, there's Pyonki, there's lots of different coding languages with lots of different names. Because for me, what I want them to know is the concept. A lot of the time when I talk to students, and I get to say to a year 6 student, what have you learned in computing your whole time in computing? What have you done? And they turn around and say stuff like, yeah, we've done Scratch. We did Scratch. You know, it really, really frustrates me because I know they haven't just done Scratch. They would have looked at computational thinking and they would have looked at different aspects of computing. If that was the kind of outcome we got from something like English, where when you said to a child, what did you do in this piece of work? And they said, oh, we've done the pencils. We've done the pencils with the book. We did the writing. You'd go, that's a failure of a lesson. But it happens all the time with computing that students think of coding, they think of Scratch, and the tool becomes the outcome. So they just say, Scratch, we're doing Scratch. What are you doing in Scratch? We're just doing it. We're just doing it all. We've done it all. What you want them to really start saying by using lots of different code is then to say, we've been looking at a concept of variables using Scratch. We've been using the concept of variables using busy code, that they're using that context first, that they're talking about language over the tool, that their outcome isn't just getting things right. So when we look at using busy code, we use it because it's a safe structure, it's leveled in a particular way that builds up confidence for staff and for students, and it goes at a particularly good pace to introduce concepts. I would always introduce concepts unplugged and then go into busy code and then let them go and use Scratch or another coding language. And that's for me always the way I would do it. So let's have a look at Code Disco Section 1. You can see that there are different sections and we're going to go through these because each one of these explains a different concept. So the first one explains the basics, so sequence. There's a tutorial, a challenge, and a coding project. This can all be put together neatly as one lesson. So the tutorial, the challenge, and the coding project can be wrapped up in a 1-hour lesson. The idea would be the basics you would teach with them. You would give them some demoing and let them have a go at it. Now that would last about 15. The challenge, gives them a challenge, and I would give them about 15 minutes to do that, because it doesn't always matter if they don't meet the challenge or finish the challenge. Bring them back, make sure everyone's seen the answer to the challenge, and then the rest of that lesson, the rest of that half an hour would be them using their knowledge in their own project. Now I'm going to go into the tutorial and open it up for you. And when you go into this tutorial, you'll see that it opens up and doesn't give you very much. It gives you a couple of blocks and it gives you a task. So it's a bit, it's similar to Scratch or any other coding. There are blocks, there is a stage, those characters will act out. But what's different to Scratch is it doesn't give you all of the tools at once. It doesn't give you the ability to change sprites or backgrounds. I love creativity and I love it in computing. It's the best place. It's such a good place to have creativity. But sometimes when you're using Scratch, children will get preoccupied with the sprite, the background. I had the most amazing year 6 student who was fantastic, but he would spend half an hour making a sprite when some of the other children had already finished and completed the task. So inside of busy code, it's a lot more simple and builds up as you go along. Now, guys, I am going to stop talking for a bit because what I want you guys to do for the next I'll try to judge time as well as I can. We'll give you 5 minutes, maybe a bit longer, is try to start using the basics, go into a challenge and go to the dance project as well. But look at Unit 1, because what this does is it gives you the basics of block coding and introduces the idea of sequence, you know, a simple linear sequence. And if you're thinking, where does this belong in a year group? I would introduce block. So some people say block coding would be introduced in year 3. I would introduce this at the end of year 2. I would want students being able to do this in year 2. Again, there are some things when you get further up about reading and angles, but this simple activity, this challenge, should be the end of Key Stage 1. They should be able to do this by the end of Key Stage 1. Now, what I'm going to do, guys, is I'm going to let you play with this now. Honestly, I will stop talking. I'll give you 5 minutes to have a play and look at busy code. Just do this one section, look at the basics, and this is what we would call sequence within the computing curriculum. Have a go. And Matthew, I'm not sure if you caught the if you can't log into busy things, there is a code behind me to help you log in. As a teacher, can you see what students are doing? So, you know, there's some functionality in busy things that you'd really, really want, right? And that is one of them. For the basics and the challenge, because they're kind of, I don't know what, like jigsaw pieces, you know, that fits in there and then it works. For the tutorials and challenge, there isn't, I mean, I'll show you. When you go in, let me just swap my screen over while that loads. When you go in here, you can start dropping in code, but you can see there's no way of saving it. But when you go into a project, because that's individual, and you want them to be a bit more creative, you will see you can actually save it on the side. So there's a way of saving it. So projects can be saved and you can see what they're doing. But for the tutorial and the challenge, because they're so kind of scaffolded, you're not going to want to record that really. It's this bit you'll record, and you can save it in busy things and access it in busy things. And you can see as I went in there, and I'll go in there again, somebody saved one in there already. Someone saved their work. But yes, you can. So one of the things people say is, well, this is quite basic, and you know, how does this move along at pace? What we'll do is today I'll show you how it does move from pace, how it does move quite quickly. I'll give you, because this is kind of the easiest one to kind of get a grip of and understand, I'm going to give you 4 more minutes and then we'll move on to our next concept and how you can introduce that. Give you a couple of more minutes and then we'll move on. But really for this, what's the outcome? You want them to be able to say at the end of this, I understand the computational thinking of sequence. I understand the concept of sequence. I understand that a computer needs a clear and precise sequence to run instructions. And really, that's all you need. That's, you know, that's the major aim at the end of year 2, is to understand sequence and be able to apply some of that knowledge in a coding way. You know, it can be block coding, but it doesn't have to be. It's when it goes into Key Stage 2 when we start to really start thinking about coding and block coding. Give you one more minute and then we'll move on to the next concept. Okay, so we'll move on from there. So, kind of sequence is the one that people understand the most. It's the one that it kind of links easily enough to kind of everyday life. What happens next is the concept of repetition. Normally I make a joke about, I'll repeat what I say, but I'm not going to do it. So, it's repetition. So repetition is vital to computing, and it's you know, when we talk about repetition, it's important for children to understand that computers aren't clever, and one of the reasons why we use computers is because of repetition. Computers do not mind doing the same thing again and again and again. If a person had to do the same job again and again and again, they would get distracted, they would get bored, they would get tired easily, and it just wouldn't work. But a computer can store information. It can do something very quickly. And one of the key reasons why we use computers is because they can repeat something again and again and again very, very quickly. So repetition is really important. It's important for students to understand that computers will repeat a step if we tell them to. And it will repeat it as many times as we want. A computer, fundamentally, can do something and repeat something forever. Although time doesn't work like that. But it can. So you can tell a computer to do something the whole time, and it will. Inside of computing, repetition is used to make things simpler, and so you don't have to put as many steps in. And that's really important for students to understand. Because, again, the higher up you get in school, the thing that people think about computing, especially like using Scratch or block coding, is the more coding there is, the better the coding is. It's a bit like children when they're doing writing, and there's some children who try to make their writing slightly bigger, so they've got more than one A4 page, and they go, my writing's better than yours, and then suddenly you're looking and you realise they've used the and like 37 times in one small bit. They need to understand, students need to understand that coding needs to be clear, concise, and sometimes the smaller the code, the more easier it is to read, is actually the best kind of code. So repetition, you can see, happens all of the time. And one of the most simple, you know, there's two kind of basic ideas here. The one on the left here, forward 100, left 120, forward 100, left 120, forward 100, left 120, can be written like that. Or you could just say repeat 3, forward 100, left 120. You can just use functions of repeat to make code smaller and easier, because computers still understand it. And on the right here, you've got when green flag is quick, forever, play sound, wait 1 second. That basically is a code to send any teacher mad, because that's just a cat meowing. Waiting 1 second, meowing again, forever. But, you know, when we use scratch and block coding, that normally happens. So repetition is the idea of loops. So you're having a loop block. Inside of block coding, it's normally a loop block. So again, guys, what we're going to go and do is we're going to go back into busy code, and we're going to look at loops. So loops is that kind of the next step. And I'd recommend this for the beginning of year 3. I'd want them to get this done in autumn 1 or definitely by autumn 2, looking at loops. And when we open up busy code again inside of loops, what you will see is the difference. Yeah, we've got the green block, which is a start, an event block. We've got the walk forwards, which was a directional block. But now you will see a loop block. What you'll see about busy things as well is that it does try to color code things with other resources. So if you were using Scratch, the colors sort of match. And what basically you're getting the children to understand is that simple instruction of blocks fitting together. You know, they are like Lego blocks, but sometimes things can move and you can change things inside of them. This slowly introduces the concept of repetition as loops, and again goes through a tutorial, a challenge, and a coding project. The idea here is, again, they can turn around at the end of this and say, I understand the computing concept of repetition because I can use a loop block in busy things to make my code smaller. So guys, I'm going to give you another 5, let's give you 6 minutes for this one. I'm going to give you 6 minutes now. Go into section 2, try to get yourselves understanding loops. And it's again, quite an easy one to understand, but give it a play and see how it works. Let's have a look at loops now. And do guys let me know if you've got any questions on the chat, or as there's only 3 of you, we can actually do audio if you want. And guys, although I'm just showing you these resources in busy code, because what I'm trying to do is pull out the concept, pull out the sequence of coding for you. Remember, there are other resources inside of LGfL that are there to move on. And that's what the resource at the beginning, Computing Spotlight, kind of draws you in with busy code, but also moves on to J2 code, which is a bit more open and gives you a bit more flexibility. But this is kind of the great way of getting confidence for yourself to understand computing a bit more, and also helps the students get the concept first. And I said I wasn't going to talk and I started talking. I apologize. And if you get to the point where you look at the challenges and you find them quite difficult, I would say the challenges are quite difficult. there's one that I find difficult. What I didn't show you as well was within at the very top where we were looking at the online guide, there are answers to the challenge as well. So if you do want to be one step ahead of your children in class, you can actually look at the answers, because there is one. And I was lucky before lockdown, I went around a couple of schools and was doing some teaching, which I don't get to do much of. And there was one challenge that I remember how to do this. And I literally, at one point, had to get my iPad out and go, what's the answer? Because they are a challenge. So you can find the answers if you think it's difficult. And they are. Okay, guys, give you one more minute and then we'll move on to the next kind of concept. And apologies, you can hear my son going woohoo. The joys of working at home. Although it looks like I'm somewhere fancy, I'm literally in my attic. Okay, one more minute, guys, and we'll move on to maybe the concepts that are a little bit more complex and hard to grab hold of, and we'll dive a bit deeper into those. Okay, so the next kind of concept that you want to be looking at for students. So we've said that sequence and block coding sequence needs to be in year 2. Repetition needs to be in year 3. This next one, selection, needs to be taught in year 4. And again, I would always go for the beginning of the year to get the concept taught so that children can use it again in a few different projects. And selection can be quite a tricky one to explain. As long as you explained selection, you explained sequence first, selection becomes just a part of that. So, for example, sequence, we talked about computers always going down the same route. You tell it to do something and it will do it, it will do it. What selection does, or the other term for it is conditionals, is it gives conditional statements. So it will do something until something happens and it stops. So with a conditional statement, you will tell a computer to do something, but if something happens, it will change. Now again, computers aren't clever, so computers only really can do true or false, on and off. So although we're, as a human, we are, like we can, have loads of different things. We look outside and go, today it's raining, I will bring an umbrella. Today is cold, I will put a jacket on. Computers can't do that. They need to be told about it. So for example, when, like when we're shopping and we're scanning in a barcode and the shopping goes into the trolley, it goes back into the basket. You know, there's that kind of thing. If barcode scanned in, I feel the weight of the food, I'll say scan another item in. If barcode gets scanned and I don't feel the weight, which is, you know, every time, I will make an annoying noise to tell you that you haven't put it in the basket. So conditionals are a way of computers looking like they have sense, you know, they've got common sense. Conditionals happen because we tell them to happen. Selection happens because we tell them to. So actions are it's a condition that always equals true or false. But for students, that's a really hard concept. You just need to make sure you apply that again into lots of real world context about hot and cold and true and false. So what we're going to do now is, you know, and what does that kind of look like in games? Well, a lot of the time, this is when we would start looking at things like quizzes. So children would make a quiz, you know, and there would be, what's 5 times 5? If 25, say correct. If false, if not right, say try again. You know, and that's kind of where we go with this, with quizzes. What we're going to do now is we're going to do exactly what we've been doing before. You're going to jump in and you're going to look at conditionals, and we're going to look at that again in busy code and how that works. And this is, I think, when busy code becomes even stronger, because it's not a simple task we're explaining. This is quite complex. And there's a reason why there isn't a challenge with it, because it is quite complex. So when we look at this, you see, right, I'm confident because I've seen the play button, but you now have the if-then statement. It's the most common conditional. If something happens, do something. So for example, if, and you've got these here, and again, they're fitted so you can actually see them joining in. So if sign says dance, then I'm gonna dance. And then when I hit play, you can see the conditional is met and it works. So again, it's giving it really heavily scaffolded, but so good to have, really simple. And then children get used to these very simple statements and they become more complex. So guys, I'm going to give you a bit more time, give you 5 more minutes, have a look at conditionals. And there's just 2 here because it does become a bit more complex. So have a go at using conditionals and kind of get the feel of it. I'm going to play along with you for this one as well. And what's really nice about the challenge here is it will start bringing in the repeat block. It will start bringing the if-then block. So you're using all of the instructions, all of the block coding. So it's building up their knowledge bit by bit. So I'm playing along with you guys. You can play along too. One of the things I would say about children do that we don't do as adults as well is hit play quickly. So for example, as an adult, you'll sit there working out a challenge for a very long time and then hit play. What's great about kids is they don't do that. They'll go in and like do something like I've just done and hit play to see what happens. And that's something you want to encourage your students to do. To start hitting play and not getting it right the first time and actually going in and debugging and honing it. So actually doing that, having a block, hitting play just to see what things do is actually a really nice, simple thing to do. I'm going to give you 3 more minutes on that, and then we're going to look at the last concept that you would introduce in computing? I'm going to give you 2 more minutes, and then we are gonna skip one of the levels, just so we can. I always skip one just to get everything fitted in nicely. I'll give you 1 more minute, and then we'll move on to the most complex, really, of all of the concepts. So within these concepts, we would have introduced basics at the end of year 2, loops in year 3, conditionals in year 4. Now, we're not going to look at events today because events is quite a simple one, and kids actually pick up in inputs and outputs very quickly. So events is looking at inputs and outputs. You know, if up is pressed, it goes forward. But the one that I think people find really hard is the idea of variables. Now, I would say that events gets taught in year 5, and I actually want to push variables really into year 5 too, because when it gets to year 6, it does get busy. And then the point of a computing curriculum is that they have all of these concepts before they get to year 6, so that when they are in year 6, they can use the concepts to make their own program. I'm just going to introduce you to variables, and don't worry, I will finish on time. So a variable is something that is a bit complex. A variable stores a piece of information in a computer's memory while the program is running. And again, it's another one of those things that makes a computer look intelligent. So where do we see things like variables? A username and password. When you log on to a school computer, put your username and password, or when you log on to a browser, it brings up your information. It can only do that because it's stored the information as a variable. So it knows when I get this variable, I can pull this data over. It's the same when you go shopping, when you do online shopping, the variables are there. But inside of computing, inside of games, where you would see variables is in lives. So, you know, if I touch this, then my variable will change up or down. Scores, question numbers, how to count. Now, we're not going to have time today to go into variables inside of busy code, but it is really, really useful to know that this, again, supports that concept, explains it to students in really, really simple ways. Variables are designed to hold information, and it's there for you. So, again, even though it's section 5, I will try to get into year 5, and so that in year 6 the curriculum is done for them, and so they can be using something like Scratch to make more open-ended projects. Now, guys, the training's going to end now, but I want you to start thinking about what you can do with your computer curriculum. What can you do right away? What can you do soon? What can you maybe start doing next term? These units are great to be used as home learning and to introduce a concept. So whatever year group you're doing and whatever you're teaching at the moment, think about next year and how you could start using them. Now, as we end, I just want to say as well, the training ends, but the support doesn't. So you can have I've got my phone number here. I've got my email address. So if there's any other questions about setting any LGfL resources up or anything you need, please just contact me. I've also got a kind of, if you pop in askbradley.lgfl.net into the browser, you'll get a Google form where you can book an appointment and we can talk a bit more about computing resources. Now, I hope you did find that useful and it gave you a little bit more understanding of the computer curriculum and how LGfL Resources can support it. You know, do look at computing.lgfl.net. Do come back and look at these resources a bit more. Hopefully, guys, that was useful. How was that, guys?
Thank you so much.
Thank you.
Brilliant, guys. Thanks very much. Have a great summer.
Bradley, you know,
You too,
it'd
bye.
be really great to share any resources that you went through. If you don't mind sharing the slides that you went through. I know you were obviously demoing live as well, but that would be really great. And I'll obviously send this through, and then just a feedback form. So for Matt, Ellen and Rebecca, if you don't mind just filling that out, because it is always so important to be able to feedback. And, you know, huge kudos to Bradley, who's been delivering back-to-back trainings all day. So I know what that's like. So rest up now, take some time away from the screen, and have a good evening.
Cool, guys. Thanks, everyone. Have a good evening. See you guys. Bye-bye.
Bye.